Yeah, so my talk tonight, my job as a software developer is not to write code. Is this a microphone? Or is it on or not on?
It's not.
All right, cool. All right. I'll stand in the middle then. Makes it easy. So this is me, Andrew Murphy, lead tech at AHC Pacific. I'm not going to go on a big diatribe about who I am. You'll learn that throughout the talk. This is what I'm going to try and convince you tonight. I'm going to try and convince you that the job of a software developer is not to write code. We're going to go through some questions, some ideas on what maybe the job of a software developer is, and then afterwards, a bit of a Q&A, and you can try and persuade me if you think I'm wrong. So, about me first. I first started programming using these, a ZX Spectrum and a BBC Micro. Does anybody remember these?
That tells your age.
Well, you shouldn't say that, that's implied.
You started very young.
So I did. I started programming at the age of 8 using these. I loved the idea that I could write code, I could do something, and something would appear on the screen. I could make something dynamic, I could do something interactive, I could make stuff, and it appeared. And I loved the fact that it was just so easy to use these things, but they really show their time. They really show how old they are when you dig into how they work. If we look at the keyboard of the ZX Spectrum, can you see how there's the letters for the keyboard, and just underneath the letters are the keywords. There's things like return, run, if. Because rather than typing if space or return space, you'd press the key that corresponded to that keyword and it would magically appear on the screen. The reason for that is because this thing only had 16 kilobytes of RAM. Not megabytes, not gigabytes, 16 kilobytes of RAM. So there wasn't enough storage to store RETURN. They stored it in 1 byte, which was the Y ASCII code. Other thing with these, there was no storage on them. Every time you turned it off and turned it on again, everything was wiped out. And the way you stored things was using audio tape. Not these fancy backup tapes, the audio tape that you used to listen to ABBA and Busted and all these embarrassing songs. And you'd plug it in using an audio cable, and you press save, and then you run to the audio recorder, press record, and hope that you've got there in time. And then when you used to load it up again, you used to run to the audio recorder, press play, run back to the machine, press load, and it'd cycle like that. Just shows you how far we've come in some number of decades since I first started programming. And of course, they all use BASIC. Everybody remembers BASIC. Most of us of my age got into programming using BASIC. Beginners, all-purpose symbolic instruction code? Yeah. Great language. Really expressive, really easy to understand. Great for getting into programming. Not so good for, arguably not so good for larger scale things. So, at the age of probably between 8 and 12, I spent all of my time writing stuff on ZX Spectrums and BBC Micros. And I just got so excited by software development. I decided that it was time to start writing PC applications. So I decided to explore C++. As a 13-year-old child, I could not get my head around this. C++ is so confusing. Pointers, null terminated strings, forget it. I couldn't do it, I really couldn't do it. So, I used the script kiddie's best invention ever, VB6. My first successful foray into software development on a PC was using VB6. Anybody professionally written VB6? Have you atoned for your sins yet, or are you still doing it? So, this actually has my one and only claim to fame. Who remembers IRC? Yeah, okay, that's a lot of people. So for those who don't remember IRC, before Stack Overflow, before Slack, before Experts Exchange, before all this stuff, the way you talk to other experts, the way you get answers to your questions, was using IRC. It was basically Slack and Stack Overflow and everything combined together. And I wrote, with a friend, the second most successful IRC chat client, called IceChat. The first most successful one was MIRC. This was the second most successful one. We had like 20,000 active users within the first 6 months of launching. One and only claim to fame. So, being the excited, enthusiastic software developer child that I was, I went to university to study software development, and I chose all the modules that didn't have exams in them. Everything I did was evaluated on coursework. So what that meant was, I had my free time to do whatever I wanted. I could spend a lot of time studying, and then I could spend even more time playing games. Enemy Territory, brilliant game, written using the Quake engine. Great. So what I did was just spend all of my university course getting my coursework out of the way, playing games. And I remember saying to a friend of mine, at the time when I was about to finish university, I remember saying to him, if this is what the job is like, writing code and playing games, I can't wait to start my career. I was wrong. So, left university, got my first job as a software developer. Woo. I worked for the local council in the UK. So they're sort of like, you know, the Melbourne Council here. I worked for one called Bradford. Of course, being a local council in the UK, which has hundreds of years, thousands of years of history, they have some absolutely incredible offices. And these are the offices for the local council, the local Bradford Council. Of course, working in IT, they put us in the 1970s Margaret Thatcher block down the road. So I didn't get that lovely, amazing office. So what I did there was I worked on geographical information systems. So this is the idea where if a councillor, you know, an MP wanted to know about the local constituents, they wanted to know statistics on age, sex, affluence, religion, things like that, they could basically draw an area on the map and the system would spit out an average of that. I also did a really interesting project on plotting the brothels in my local town. If you want to know more about that, ask me afterwards, because there's some really interesting statistics on where brothels are. They're not where you think they are. So I started my job in this geographical information systems role, and I was really excited. I was going into work and I was like, can't wait to get there, get my computer on, start hacking away at the code and build something. So I got into the work and I wasn't writing code. I spent the first few months doing things that weren't writing code. And I started wondering to myself, is it because they don't trust me? Maybe it's because I'm a new developer. But I wasn't writing code. What I was doing was configuring database systems, configuring server monitors, learning things, learning new frameworks, learning new tools, just basically everything that you do before you get to code. And of course, meetings. Lots and lots of meetings. Meetings about a project that's about to start, meetings about a project that is finished, meetings about architecture, meetings about process, meetings about meetings. Didn't know you could have a meeting about a meeting. We'd have meetings about meetings we were going to have, and meetings about meetings we'd had. It was like this recursive loop of meetings. And this is really what went on for 3 months, for 6 months, and I still wasn't writing any code. And I started feeling quite depressed. I started feeling like, you know, why am I here? Do they not trust me? Why am I not writing code? I felt like all these things, this meetings, these configuring things and setting things up, I started feeling like there were these things that I had to do and push out of the way so I could get onto the real work of writing code. And however hard I tried, I couldn't push these things out of the way. And I actually started fearing for my job. I really started worrying that the reason why I wasn't doing these things was because I wasn't good enough. And that somebody was going to find out, somebody was going to realize that I wasn't good enough to write the code, and that's why they were doing these things. That's why they were making me do these things. Unfortunately, I ended up leaving this role, not because of that, but I didn't really learn in that role. But luckily, in my next role, complete about face, I went from working for this geographical information systems department to working for a multinational manufacturing retailer. So what we actually made, does anybody recognise this? If you're an English person, you might recognise it. No? Is there any English people in? It's a what?
It's a lorry.
Speak up. A lorry? Oh, this one. No, nobody recognises it. All right. What that is a trouser press. This is a uniquely English invention. So, proper English gentleman's trousers, they have a crease down the front. Have you ever noticed? Like, the ones you wear with your suit, you have a crease. And proper English gentlemen don't iron their trousers. They use a trouser press. What you do is you fold the trousers up and you put them in this thing, and it's basically like a big flat vertical iron, and it just compresses it, heats it up, and it gives you that lovely crease down the middle. Very English invention. So I work for this company that made these, and they're all over the UK. If you go into a hotel in the UK, a reasonably upmarket hotel, you'll find one of these. And undoubtedly it's been made by this company, Corby of Windsor. So I work for this company, and they had massive problems with stock management. Their stock management was effectively Barry going, have we got any stock, John? And John shouting back, we got about 3. And Barry going, thanks, John. And then telling the customer. That was their stock management system. So you can imagine the issues they had. So we wanted to build something that managed the stock for them. And not only was it going to manage the stock, it was going to manage the orders, it was going to manage the process, it was going to manage the ordering for the factory in China, and all of this. So this was the project, and I was the only developer on this project. In fact, I was the only developer in the entire company. I had been hired to build this by myself. But I did have a mentor. But this mentor wasn't a software developer. This mentor was the operations director. He was actually a mechanical engineer by trade, so he was an engineering specialist. And he was a brilliant mentor for teaching me how to build software systems. And he taught me engineering techniques, engineering practicalities, engineering processes, and how they could be applied to the building of the software. So he taught me about taking reusable parts and combining them together. He taught me about doing requirements analysis and how we do that. He taught me about how we can check whether things are working by doing monitoring and analyses. He taught me all of these things, down to the level of how to organise my day, how to be a productive employee. And it really changed the way that I viewed things, because the other thing he did is he took me into the warehouse. And he took me into the shops that were selling these things. And he actually had me there in the warehouse, packing things, moving things around, doing stock audits, checking goods in, checking goods out, and actually doing the job that I was writing the software to do, so that I could appreciate what the job was, what the pain points were, everything about how what I was doing was going to make life better for the people in the warehouse, for the people in the stores, everything about that. And it was about this time when I suddenly realised that everything that I hated about my last role, or everything I was worried about with my last role, they were happening for a reason. I was doing these things for a reason. I was doing the monitoring and the meetings for a reason. And it twigged in my head what that reason was. It's not your job to write code. It's your job to solve problems and provide value to end users. This is crucially what I realized I was hired to do. It didn't matter that I was writing code. The value the business was getting out of me was to solve their problems. And whether that involved the writing of code, or that involved the configuring of software, or the using of something else, the composition of reusable parts altogether, it didn't matter to them. All they cared about was their problem was solved, and that's what I was hired to do. And also part of that is providing value to end users. If I'm doing this talk in front of an open source audience, I definitely leave this in there because it's important to open source people, but if you do this in front of a business person, they're just going to go straight away. Well, providing value to end users is the same as solving a business problem. It's important to kind of realise that as well. If you provide value to somebody, you're solving some sort of business problem, even if that's an increase in optimisation. But we like open source, so I'll leave that in there. Then I moved on. I moved on to the company that I work for now, and I got the amazing offices. But of course, working in IT, basement, I could just about see the sky. If I sort of craned and looked up, I could see if it was raining or not, and that was pretty much about it. But what I do here is we do complex financial models. We work with the likes of banks and investment advisors and superannuation funds, and we try and make simple things complex. Superannuation is a mind screw. How can we best make that simple? And this was where I started realizing something else about the job of a software developer that's important, that I haven't talked about yet. And this is why I also make a confession. Do you remember this slide from the beginning about who I am and where I come from? I lied a little bit. That's my job title. It's got the word consultant in it. I'm sorry. I know that's kind of a little bit of a loaded word, but I want to kind of explain what a consultant is, because a consultant is not somebody standing in a suit smiling. A consultant is not somebody pointing at a computer smiling, pointing at a flipboard, not smiling. He's obviously not happy about what's on the flipboard. But to me, a consultant is somebody that actually likes and sees the value in talking to people and listening to them. That's what a consultant is to me. It's not somebody that's there to go and sell you what you don't need. It's not somebody there to sell you something necessarily at all. It's just somebody that likes understanding where people are coming from and what you can do to help them. So that's why that's the only reason I have consultant in my job title. So there really is a value in understanding people and understanding where they're coming from, because it helps you get the best out of the software for the client. So I've talked a lot about who I am and where I came from, and hopefully you've got a little bit of value from that, and if you haven't, apologies. But what I want to go through now is I've talked about all of these things. I just want to put them in a kind of a little bit more of a nutshell for you to go through them and explain them a little bit further. So this is kind of what I see, high level, very, very high level, and we can discuss if you really have a strong opinion or if you think something else should go on here afterwards. But this is really high level what I think of as software development. We've got the things we do before we write code. We've got communication that I just talked about, talking to people. We've got thinking. Don't underestimate the value of thinking about the problem. And we've got the design and architecture where we actually take that thinking and do something with it. And then we've got the code itself. And after we've written the code, we've got to document it, we've got to test it, we've got to do all of these things. And I'm just going to quickly go through some of them and talk about them. So first of all, we'll go through what we do before we actually write the code. Communication. So just like I talked about before, it's really important, in my opinion, that having somebody technical at the start of a project, discussing things with the business people, whether that's internal clients or external clients. Don't underestimate the value of having somebody technical in that meeting straight away. It just sets things off on the right foot. It puts the client at rest that you actually know what you're doing. If you've got a salesperson that doesn't really understand tech, then they might not be the right person to solely go to that meeting. Maybe you need a tech person. If they've got tech people in the meeting as well, definitely send a tech person. The benefit of having the potential clients or the client's tech person going, yeah, they know what they're talking about, that just puts everybody's mind at rest. And don't think about sales as something you don't want to do. Think about it like this. I'm really proud of what we do as an organisation. I'm really proud of what we produce. I honestly believe it's the best on the market in our area. And I'm paid to show it off. I'm a massive show-off. If I wasn't, I wouldn't be stood here. But I'm paid to go to a client, stand there, and show off. That's amazing. Thinking. Like I said before, thinking's important. Thinking before you do something is important. But I don't just necessarily mean about the projects. Like in general, as software developers, to me what's important is thinking critically about things. Why do you hold the opinions you hold? Where did those opinions come from? Should you question them? Should you test them? Should you spend time evaluating them? And then, of course, apply those same principles to the project, but don't necessarily always do that. Always seem to be questioning your views. So of course, following on from thinking is where we actually go and we do the design and the architecture. And as much as we don't like doing this, the one thing that I always think about is that if you can solve the problem you're having by using less code, how can that not always be the preferable solution? Of course, you've got to balance out time and you know the kind of practicalities of spending time on the thinking versus the doing. But ultimately, if you can spend more time thinking than doing and solve the same problem, you've got less to maintain going forward. How is that not better? So we've done all of this. We've decided what we're going to build. We've decided how we're going to build it. We've decided how it's going to work. Then we write the code. Do we? Do we write the code? Maybe we've discovered that at this point, we don't need to write any code. Maybe there's something that already exists on the market that can solve the problem for us. Maybe there's existing things that we can take and plug together to solve the problem. The client doesn't care. The client doesn't care whether you've written the code or not. All the client cares about is whether or not you've solved their problem. I'm going to keep using the word client, but like internal client, external client, whoever wants their problem solved. They don't care, they just want their problem solved. So do we actually need to write the code? That's quite an important question. If you don't write code, you've got less to maintain. Cost of maintenance versus cost of subscriptions, it's quite often the right answer to not write any code. So then we go on to what we do after we have written the code or not written the code and use something else. So documentation. I'm not going to bang on about documentation. We all know it's good. We all know we should do it. We all know we don't do it well. The one thing I'm going to point out is this great quote that I wish I could remember where I saw it from, but code is read 10 times more than it's written. That one fact should make you realize that code is almost a read-only text file. You read it way more than you write it, and so the way you write your code should be important. The one thing I am going to talk about on documentation is not code documentation, it's decision documentation. How often have you come back to something in 6 months, a year, looked at a decision that somebody else or you have made and gone, why did they do that? Why did they make that decision? That's stupid. And the reason why you say that is because you've forgotten or don't know why the decision was made in the first place. Most people aren't idiots. Most people will make a reasonable decision based on reasonable information. But 6 or 12 months down the line, if you don't know why they made the decision, you might make the same mistake that they were trying to avoid. So what I honestly believe that's more important than code documentation is documenting why you made decisions, documenting the information you had, the decision you made and why you made it, and then 6 months, 12 months down the line, when you come back to it, you can look at it and you can go, oh, okay, I made that decision because, but now I also know, therefore I'm now going to decide blah, and document that as well. Testing. Again, like documentation, I'm not going to harp on about it. We all know we need to do it. We all know we don't do it. Most of us don't do it well enough. But the just fuck it, ship it mentality doesn't work in the long run. We all know that. So why do we still do it? You know, I'm as guilty as this for everybody. And the only answer is that the kind of corporate cultures that make us do these things. And if you're in that kind of culture, just leave. You owe it to yourself, you owe it to your clients, you owe it to the end users, you owe it to your career, to being in a job where the people there share the same values as you, share the same values about it's important to do it right than to do it fast. So that's the only thing I want to say on testing. Monitoring and testing hypotheses. This is a big thing for me. I'll spend a little bit more time on this. So how often do we launch something and then go, job done, walk away? We do that all the time, but we shouldn't. We should really think about how do we define the success of this project? How do we define what success looks like before we start the project? And then how do we put the things in place, the jigsaw pieces in place, so that by the time we get to the end of the project, we know if we've been successful? That's really crucial, because how do you know if you've solved the problem if you haven't defined what solving it looks like. And it doesn't have to be a Boolean true false. It can be some qualitative or quantitative measure of success, but it's really important to be thinking about success, in my opinion, before you start the project, because how do you know if you've finished the project? How do we know if you've done it well if you don't measure it? It's as simple as that. Right? It's important to think about those things. A small change that we can do throughout the project or after the project can have a huge impact on that success measure. And if we're not thinking about that and not monitoring that, we don't know. So a little bit outside of projects and on to kind of more about what I think is important for a software developer is the cruciality of learning, experimenting and exploring. If you're excited and enthused about technology, you're doing this already. You're playing with things, you're doing something, you're trying something new, you're trying a new framework. And of course, you speak to a recruiter on, any recruiters in? Phew, right. You speak to a recruiter on the phone, and they say, you need to have 5 years of React.js experience, and 10 years of this thing that's only been out for 8 years, and they tell you all these things, and you need to know unicornpoop.js, and then you want to go, what the hell is unicornpoop.js? That's what they tell you is important, and I really disagree with that. I think it's more important to be excited and enthusiastic and explore and learn and play than it is to have knowledge of a particular framework at a particular time. Because what companies want is somebody who's going to be excited, somebody who's going to be enthused, somebody who's going to keep themselves up to date because they're legitimately interested and excited by these things. So don't do this because a recruiter tells you that it's important for your career. Do it because it's fun. Do it because you enjoy doing it. Do it because it improves your problem-solving abilities and it feeds your enthusiasm. That's more important than what a recruiter says on the end of a phone. Code reviews, training, mentoring. Code reviews are brilliant for senior developers. They're brilliant for junior developers, but they're just as good for senior developers because you're not as clever as you think you are. As clever as you think you are, you're almost there, but you're not there. And somebody else will do something, and you'll go, that's brilliant, that is. I wish I'd known that. So reviewing somebody else's code, as much as checking for errors and as much as doing all of the good things about it, it's great for your own learning. It's great for seeing something new and discussing interesting ideas and hypotheses. And it's great just for that, let alone the business benefits of code reviews. And I think there's a little bit of a stigma on code reviews in our industry, and it stems from this whole imposter syndrome thing of we don't want to be found out that we don't know what we're doing, but everybody is learning, everybody is doing something new that they've never done before. If it was done before, there'd be a piece of software that did it and you wouldn't be sat where you are. So code reviews are really important, and training and mentoring, something that I really think we don't do well in the industry is a lot of other engineering disciplines, and we can have a discussion on whether software development is engineering or not, but a lot of engineering disciplines have this idea of apprenticeships. They go into the career and they learn on their job and they do it. They don't do this 5-year master's degree and then go into industry and go, I'm a software developer now. They have this long iterative learning process, and that's really what training and mentoring should be. We should be doing that in software development more, because you don't learn what you need to know in university. Has anybody done a software development degree? Did you think it was worthwhile? Who else? Did you think it was worthwhile?
It got me a visa.
Good answer. You got him a visa. Okay, fair enough. I can understand that. So it is important that we learn the academic side, definitely, and even on it, these apprenticeship courses for other engineering disciplines, there's a certain element of academia about it, but you learn the best by doing the job, and there should be more focus on getting people into work and doing the job. So that was a whirlwind tour is really heading towards, and we can talk about this later, and you can tell me if I'm missing something important. But this is one quote that I think really sums up the spirit of what I'm trying to say. In the future, everyone will be a software engineer, and barely anyone will know how to code. What that means to me is we don't know what the future of writing code looks like. Maybe AI will write code. Who knows? We don't know what code will look like. But problems will always exist. Problems will always need to be solved. People will always need to do something quicker, faster, better, and understand what they need to do quicker, faster, and better. These things will always exist, even if it's not a human sat there writing code. And if you have those skills, if you understand that that's what the role of a software developer is, it's not to hack out code, then there'll always be a job for you. So I really liked how that looked, and my egotism kind of flicks in a little bit, so I had to do one for myself. So this is kind of the crux of the entire thing I'm trying to say. My worth as a software engineer is not in how well I write code. It's in my ability to solve problems and provide value to end users. That's really what I see personally as my value, and that's the hypothesis I'm putting forward. Thank you. Does anybody want to tell me I'm wrong?
I can't agree more with you, what you've been saying. But as you rightly said about recruiters and also managers, I had a recent experience with my own manager where I wanted to get into another project, been in the industry for perhaps like older than you, over 10 years. And
Thank you, by the way.
No problem. And his statement was, okay, you don't know the BLA framework, and we need someone who can just go and hit the ground.
Yeah.
And I was like, oh, hang on, I've been in the industry for years and I've done all these other things. I mean, this is just one framework. I can go and learn. And I didn't get this thing because of that. And that was very disappointing. So perhaps it's not us, but those people who should be learning these lessons.
I definitely agree with you. I agree with you 100%. I think it's a major problem in our industry that the people that are responsible for hiring developers don't have this message in their head. And I'm not really sure what the solution is, because what's really difficult is when you're hiring people, you get 100, 200. I had a job offer on, I had a job advert on Seek, and I got 457 job applicants. How do I go through them and narrow them down? I mean, your scenario is slightly different in that, the boss knew you, but it's really difficult when you're recruiting somebody to find a way to measure these skills and to kind of get the answer as to whether or not somebody is a good problem solver, irrespective of what frameworks they know. And I think because it's so difficult to do that, people don't try. And people don't see the value in somebody that is a good problem solver. I'd much rather hire somebody that has domain experience, that has great problem solver, and doesn't know the framework, than somebody that knows the framework and has no relevant experience. Like, to me, the other person is more valuable, because frameworks are frameworks. And how long does a framework last anyway? 5 years, 10 years maximum? And even if it lasts that long, it's iterating. Look at what's changed in .NET over the past 3 years with .NET Core and all of that. It's completely different. You're absolutely right. There's too much focus on frameworks and technologies, and I wish I could tell you I have an answer for it, but I really don't. I welcome if anybody has any answers, because it really is an issue.
I was thinking here, perhaps a definition might be useful, because a software engineer may not be the exact same thing as a technical architect.
Yes.
Or a programmer or something. I've written an article that says I am not a software engineer because I don't have a master's degree and I'm not an accredited member of the engineering association with all of the risks and responsibilities that you have as an engineer.
Yes.
However, I am what used to be called a programmer, that now tends to be all sorts of other terms. Developer is the latest, software developer is the latest term.
coder, yeah.
But what you're describing here is very much, I would call a consultant or an architectural thing, as if you call yourself an engineer but you're not writing code.
Yeah.
You're, as you say, you're knowledgeable about frameworks and code, but you may not necessarily be writing it. But
Yeah.
it's a degree, it's a separation of responsibilities of somebody who thinks about it and is an architect
Yeah.
of a system can certainly be separate from the person who knows nothing at all about that, is actually not doesn't care about end user value, but cares about the quality of the code that they actually write.
Yeah, no, I do agree with you. I think there's definitely a definition. And there's a, like you said, there's a whole argument on is our practice even an engineering discipline. That's a whole big discussion. There's a meetup recently, Software Outbound, and there's a guy, I really can't remember his name. He did a talk there on kind of the history of engineering and analysing whether software engineering fit within that definition, and that's definitely a whole big discussion in itself, and I recommend you definitely watch that YouTube video. It's on YouTube. But I think the message of what I'm trying to say, although I agree with you, is that even if you're just somebody who loves writing code and is brilliant at writing code and doesn't want to, doesn't care, doesn't see the value in understanding the wider picture, I want to challenge that opinion of theirs and say that the best way to get the best work out of somebody is if they have some wider understanding of what problem they're trying to solve, and whether that comes down to the technical architecture, whether that comes down to UML diagrams and all that stuff that architects like. The crucial point of understanding the problem that is being solved and how what you're doing contributes towards that problem, I think that essence that's there applies to everybody, whatever their job title is.
That also is somewhat influenced by the size of the organisation that you're working in.
Yeah.
If you're in a very small group where you are able to play multiple roles of architects down to developer, then yes, I agree. You will always have that end user value in mind. But if you're in a very much a larger organisation where you've got two people who are architects that far away, and you've got database admins over there, and you've got days here, and front ends there, and back ends there, and yada yada, then you may not be able to see the bigger picture.
That comes down to the managers.
You may be prevented from contributing to it because you're just a tiny cog in a huge big machine.
And that goes back to the problem we were just discussing of this isn't necessarily just an issue with whatever your job title you call yourself, programmer, code or whatever. It's not just an issue with those people, it's an issue with everybody. And the people that see value and want to understand the larger picture are quite often are not allowed to do that. And that's definitely an issue that I would agree with.
It seems to be the rise in larger organisations, in their interest in what's so-called agile program development methods seems to be encouraging exactly that because of the cross-discipline groupings that you tend to get. That definitely helps everybody be informed in that way.
I really, really recommend you watch that YouTube video I was talking about. It's on the Zendesk YouTube channel. It's Software Art Thou, Real Software Engineering, I think is what it's called. It really makes you think in terms of that.
What do you do when the state of business problem doesn't deliver value to the person asking for it? For example, they ask you for a tool which you know won't actually help them.
So are you saying what happens if when you know what you're going to deliver won't add value, or when you've delivered something that you thought would add value and it doesn't?
No, when the request, so you get the business request, please build us this, or say they ask you to build like a database, but they don't have any user training for it, or the users don't really want it, sort of thing.
Yeah.
And so you know, in just from them what they're requesting, that then solving their business problem won't actually deliver value to them.
Yeah, I think that's a whole talk in itself in terms of how to best get your point across, communicate and influence people. And I think, again, that's something that historically we don't do very well as techies, and it's something that is quite a big thing, and again, a lot of it goes down to infrastructure, organisational infrastructure and things. But I think, to me, one of the best things I ever learned is people are not always influenced in the same way. And I'm using the word influence, and it's an awful word, but what I really mean is trying to get somebody to understand your point of view. People are influenced in various ways, and recognising that everybody isn't influenced by the same things you're influenced by is a crucial point in how you make somebody understand your point of view. And what we do as humans is we try and convince somebody of something. And then when they don't seem convinced, we double down on the way that we convince them. And why is that going to work? You know, why is trying to do the same thing twice as hard going to really influence somebody and get them to understand it? So I think the crucial thing that I think about when I think about making somebody understand my point of view is what things are they influenced by? What techniques are they influenced by? You know, are they influenced by logic? You know, if you're a programmer, chances are you're influenced by logic, and that's the way that you're naturally going to influence somebody else. But if it's a manager, if it's somebody higher up in the organisation, they might not be influenced by that. They might be influenced by prior art or by enthusiasm and emotion, and you know, recognising what somebody is influenced by, and I don't mean in a bad way. You know, influencing them to understand your point of view. That's kind of an important thing. That's probably what I'd say is try and work out what's the best way.
What best way to talk to them?
Yeah.
To communicate with them.
I think so. Yeah. Does that answer your question?
No, I thought it was really good.
So, thank you.
We're hiring, and well, we're doing interviews.
Yes.
And how you can check this valuable solve problem skills during 1 hour?
Yeah.
Not coding?
Yes, it's hard. It's hard, and this kind of comes down to the core issue with this, and why we don't do it is because it is so hard to test these things. And I think, you know, there's techniques to do it, and a lot of it is looking at problem solving and trying to interview somebody on the way they solve problems, and getting somebody to solve a problem in front of you and verbalise the way they're solving that problem as they're doing it. That's a good way to kind of get those things across. But it's not perfect, and I wish I had an answer for you. But it is an issue, and to me, focusing less on the tech and more on the problem solving is the best way I found of trying to do that. But I've not found a really good way to do that in an interview. If I did, I'd tell you what it was on the slides. If you come across one, please let me know.
We'll ask in the call.
Has anybody got a good idea?
Basically scenario and whiteboarding.
Yeah, I mean that's basically what I meant about solving the problem. But yeah, that's the best way.
That's literally, I think, all you can do really, like in an hour period. Yeah.
Yeah, I mean we use, and again it's a little bit techy, but we use FizzBuzz, but we use FizzBuzz asking somebody to solve it in a made-up programming language, and asking them to not just go onto the whiteboard and write it all out without saying anything and then tell us about it. We ask them to give us their internal monologue as they're trying to solve the problem, and that seems to work quite well.
So if delivering business value is one of the things that you think is really important, how does FizzBuzz really address the candidates?
It's the way you use it. It's not about having. It's not about looking at it and checking the validity of the code. It's about looking at how they solve the problem, what their internal thought monologue is as they solve the problem. That's the thing that I'm looking at. I couldn't care if their code on the whiteboard compiles and runs and gives the right answer, but what I care about is how they go through trying to solve it. And again, I'm not saying it's...
Which solves problem-solving skills,
Yeah.
but less so about domain exploration skills.
Yeah, agreed. Again, I don't have all the answers. Yeah, but it's a very good point. If nobody caught that, what was said is that my idea does business problem solving, but doesn't actually find out if somebody has the ability to look at a domain, understand a domain, and make decisions based on it, which is a very valid point. How are we doing for time?
We're
probably Peter should be here in a couple minutes.
So one more question,
Probably
maybe?
for one more question, and then
Yeah.
we'll break and perhaps.
So, I mean, practically in Australia, is there a trade level track into an IT job, or is that basically gone now? It's universities only?
I can't speak for Australia. If you haven't noticed, I'm not Australian. But,
Yeah.
in terms of the UK, it's not there as much as it should be. I think it's better here in Australia. You know, we have these things like General Assembly and things like that, which is heading in the right direction. I'm not sure that they're the right answer, but at least they've identified the problem and are working towards it. In the UK, we don't really have much like that. I think there's what they do well is get people to what General Assembly and stuff like that do well is get them to a certain level of ability. But then we don't pick that up well in industry. We don't take people that have got this base level of abilities and give them the support they need in industry. So that's probably where I'd say the improvements in industry have to come from, is the idea of a graduate software developer being the lowest kind of level that we allow in our organisations. I think that has to be rethought in itself, and there has to be, you know, some kind of apprentice software developer level, which is somebody who has got the basic concepts and importantly enthusiastic, excited, interested, driven to learn more, and providing them the support in the organisation to drive them forward to add real value to the business.
So there's a big gap there between, let's say, a 4-year apprenticeship and a 4-week coding campus.
Is there? Is there? That's an interesting question in itself. I mean, you can argue that somebody's learned a lot of academic information, but have they actually learned the skills that are valuable to the organisation? And again, I'd send you towards that software engineering talk I talked about. He talks about the idea that, you know, there's these two large parts of software engineering. There's academic software engineering, and there's what actually happens in industry, and they are poles apart. You know, the whole idea of waterfall and stuff like that, that didn't come from industry, that came from academia. Industry wanted to do agile and wanted to do all of this kind of iterative approaches, and academia looked at it completely wrong and said, let's do it the same way we build a bridge, and misconstrued who the important parties are and what the important bits were, and didn't get that right. So I'd agree there's definitely something to be learned from data structures and standard algorithms and, you know, understanding certain building blocks, but my personal opinion is that 75% of a university course is not applicable to the workforce. Okay.
Thank you very much.
Yep, thank you.